Could you imagine visiting the past or future? What era would you choose? What if changing the past led to a different present? How would that impact our lives? If you could meet your future self, what burning questions would you ask? Hey there, fellow time enthusiasts. Welcome back to our channel. Today, we're diving into the mind-bending realm of time travel. Buckle up, because we're about to unravel the mysteries and complexities of this fascinating concept. Have you ever wondered if time travel is possible? Well, stick around as we explore this mind-boggling topic together. What is time travel? In simple words, time travel is the idea of moving between different points in time. It's like hopping between moments in history or peeking into the future. It's a concept that has captured the imagination of many, thanks to its presence in pop culture. Types of time travel. 1. Fixed timeline. In this concept, events in the past cannot be changed. Any attempt to alter the past would lead to actions that actually contribute to the events that have already occurred. This idea suggests that time is immutable and predestined. 2. Dynamic timeline. This type of time travel allows for changes in the past, leading to branching timelines or alternate realities. Each action in the past creates a new timeline with potentially different outcomes, avoiding the paradoxes associated with fixed timelines. 3. Multiverse theory. This concept proposes that every possible action or choice in the past leads to the creation of a new parallel universe. Time travelers would enter a separate reality when they change the past, avoiding the grandfather paradox by not affecting their own existence. 4. Bootstrap paradox. This paradox involves a time traveler introducing an object or information from the future into the past, which then becomes the basis for the same object or information to exist in the future. The origin of the object becomes unclear. Did it have a beginning, or is it caught in a loop of causality? 5. Predestination paradox. In this scenario, a time traveler's actions inadvertently lead to the events they were trying to prevent. Their actions essentially ensure that history unfolds as it originally did, creating a loop where their presence becomes a necessary part of the past. 6. Alternate universes or parallel worlds. This concept suggests that each decision or event creates a new universe, resulting in a vast web of parallel worlds where different versions of reality coexist. Time travelers can interact with these universes and explore the outcomes of various choices. 7. Closed time-like curve, CTC. This theoretical concept involves a path in spacetime that loops back onto itself, allowing events from the past to influence events in the future. CTCs are a mathematical solution to Einstein's equations of general relativity but raise questions about causality and logical consistency. 8. One-way time travel. This idea involves traveling forward in time at a faster rate than usual, as predicted by the theory of relativity. This type of time travel is theoretically possible through the effects of time dilation, where objects moving at high speeds experience time differently. Question: which one is really possible as per today's knowledge of science? Time dilation, a real possibility. Time dilation, as predicted by Einstein's theory of relativity, is the most feasible form of time travel. In simple terms, it's the effect that occurs when an object moves at very high speeds or experiences strong gravitational fields, causing time to pass differently for the object compared to a stationary observer. Understanding Einstein's theory. Einstein's theory of relativity. Albert Einstein's theory of relativity consists of two main parts: the special theory of relativity and the general theory of relativity. Both theories revolutionized our understanding of space, time, and gravity. Special theory of relativity. Einstein's special theory of relativity, published in 1905, introduced groundbreaking concepts. One of its key tenets is that the laws of physics are the same for all non-accelerating observers, regardless of their relative motion. This principle challenged classical notions of absolute time and space. Time dilation, a consequence of special relativity. Time dilation is a phenomenon that emerges from the special theory of relativity. It states that time passes more slowly for an object in motion relative to a stationary observer. This effect becomes particularly significant as an object's speed approaches the speed of light. The relativity of simultaneity. Another crucial aspect of special relativity is the relativity of simultaneity. This means that events that appear simultaneous to one observer may not appear simultaneous to another observer in relative motion. As a result, time can appear to flow differently for different observers, leading to time dilation. General theory of relativity and gravity. Einstein's general theory of relativity, published in 1915, extended his ideas to include gravity. It describes gravity as the curvature of spacetime caused by mass and energy. Massive objects, such as planets and stars, create curvature in spacetime, and the curvature affects the paths that objects and light take through space. Curvature of spacetime and time dilation. In the presence of a massive object, such as a planet or a black hole, the curvature of spacetime becomes more pronounced. As a result, time flows at a different rate for an object in a strong gravitational field compared to an object in a weaker field. This effect is known as gravitational time dilation. This was for part 1, and in part 2 we will provide a simple example to comprehend the theory, and will also discuss how you can watch past by just watching at sky at night from your own roof. If you enjoyed this video, make sure to hit the subscribe button and bell icon to be notified when the part 2 arrives. Comment below your opinion what you think. Is there any probability of time travel?